Hey everyone, this is Harishankar and today I'll be walking you through my Pathfinder project, a Node.js and Express backend that I've Dockerized, deployed on Kubernetes and integrated with Prometheus and Grafana for real-time monitoring. In this short demo, I'll show you how everything connects from the Docker image to the Kubernetes setup, the metrics collection and finally the live Grafana dashboard. So this is my project. Both front end and back end are there. Front end I've done using Flutter for a mobile app, but we will not be touching that today. We'll be looking at the back end. So in the backend, I have set up the Docker file. So here's the Docker file that builds the backend image, runs as non-root and exposes the app. Here I'm using Node LTS Alpine for small images, and then I create a work app folder to switch to a non-user and install dependencies, copy source and exposes port 3000. And then finally I am running npm start. This is the Docker ignore file. These files are specified such that this folder or files will be ignored while building so as to reduce the file size. That is the whole concept of Dockerization. So this is all about Docker. And then moving on to Kubernetes, all the Kubernetes manifests or the .yaml files are stored in this folder K8s. It has deployment.yaml, service.yaml, Grafana deployment.yaml and Prometheus.yaml. So deployment.yaml has all the rules and regulations to be followed while deploying. So for example here replicas 3, that means always there will be 3 replicas of the backend or whatever pods you are deploying. This is used for self-healing, as if one goes down automatically another one comes back up. I'll show you the self-healing in the upcoming section. And then here the containers, the pods which are to be deployed, these are the properties of that. So image being pulled is this image. So this is the image I uploaded to Docker Hub after Dockerizing the backend. And then image pull policy is set to never because the image is built locally in the Minikube. And then these are the resources, like the maximum resources allowed, the limit of the CPU and memory and such. And then this is the TCP, the port which is it opening on. And this file is a service.yaml. So service.yaml is used as the rules of the network while using Kubernetes pods. So here a node port service exposes the app inside the cluster and externally on a node port. So here it selects the ports with label Pathfinder and routes to the port 5050 and opens node port 30008. So that's what this service.yaml does. The Prometheus.yaml and Grafana deployment.yaml are used to visualize the data, various type of data. So Prometheus YAML scrapes my node's backend / metrics endpoint, and as you can see, I'll show you the app.js. In my app, I expose / metrics using the prom client, and Prometheus scrapes this endpoint at intervals to collect metrics. And then Grafana deployment. This deploys Grafana and exposes it on port 3000. Here you can see the login credentials are configured via environment variables, and I'll show you in a minute. Like I'll port forward to access Grafana locally. Right now this is present in a cluster IP, so I'll port forward it to a localhost 3000 to access it locally via a web browser. That's all about the Docker file and the Kubernetes manifests. Now we'll move on to how this Kubernetes is being deployed, and I'll show you the visualization using Grafana and Prometheus. So for that, I'll be using a container called Minikube. So Minikube is like a mini version of Kubernetes running on your laptop. It lets you practice everything from deploying pods to monitoring with Prometheus without needing a real cloud cluster. So Kubernetes is really expensive and it's a bit complicated. So for development and testing purposes, we use Minikube, which is a container running on Docker app. So for using Minikube, you have to first pull an image from Docker and then run the Minikube as a container inside Docker and then connect to it. So I have set up most of the parts, and I'll show you that I set up. So this is the Docker desktop, and then you can see the Minikube. So it's currently running, and then I have pulled it before. It takes a lot of time, so that's why I'm avoiding it in the video. And to test it out, I can show you. So as you can see, everything is running, up and running. This file contains all the commands I've used. So this is how you start the Minikube container, Minikube start, and then this is how you set the Docker environment for the Minikube. And then building Docker image is only if you haven't uploaded it in the Docker Hub. For now, I have uploaded in the Docker Hub, so I'm directly pulling from it. This is not necessary. Otherwise, you have to build it and then pull it into the Minikube. So here, this is for the Kubernetes part. So Kubernetes apply fks. So this will apply the YAML files in the KTS folder recursively, and that's the setup part. Now these commands I'll be using. I'll show you how to do it. And the last 3 commands are just for testing. After we have set up everything, we can just test the working of the backend server. Now I'll show you the self-healing property. According to this deployment.yaml we have set up, there should be always 3 replicas of the pods we are using. These are the pods which are running right now. And then I'm going to delete a pod. I'm not going to delete the second pod. So as soon as I click enter, it's being terminated, and then as soon as it's terminating, another new instance is being popped up. So that's the basic of self-healing property. Should show you clearly. See that this instance has just now been popped up. It's been just 16 seconds, and this thing is nowhere to be found. That's deleted, and then a new thing popped up. Now I'll show you the visualization I've set up using Grafana and Prometheus to see the characteristics of the pods. And for that, you have to do some prerequisites. The first one will be to port forward the Grafana. So by default, the Grafana will be in some random public IP. So for our convenience, I have forwarded it to localhost 3000 port 80. And then when we go to this localhost 3000, you will be asked to log in to Grafana. So by default, the username is admin, and for the password, you just run this command, and then you will get this password. I'm going to copy paste it. And it will give you the dashboard. So if you go to the dashboard, this is what I've already set up. What all I've set up here is CPU usage, memory usage, pod restarts, pod uptime, node CPU percentage, and memory percentage. So here you can see the CPU usage of each pods I've deployed till now. And as you can see here, the red one, which is this pod, stops here. That means that I've either deleted or it must have gone down. And then as soon as it's gone down, an orange one, it comes up. That shows the self-healing here also. And then the CPU utilization varies according to the endpoints which are being hit. And then that same goes to memory usage. You can see various colors are being used to represent the pods. Then pod restarts. This shows you the number of times each pod has restarted. And pod uptime. This shows you how much time the pod has been up for each pod. So as you can see, 3 hours I had deployed it long time ago, and then these are recently deployed ones. And then not CPU percentage and memory percentage is the average CPU percentage and memory percentage utilized. I have paused this for now. The refresh, you can set it to refresh every 10 seconds, so it will be live, and then you can see the metrics according to your wish. So this is the last 6 hours. If you want to see a recent one, this last 5 minutes, and then depends on you. So this is what my project is. To summarize, I've Dockerized the Node and Express backend, deployed it to a Kubernetes with a deployment service, and Prometheus scapes my app's metrics, and Grafana visualizes both pod level and node level performances.